Hello everyone, it's Olli here again. Last time we explored the use of the camera array tool in great detail. Now I'll show you how we can create different synthetic environments and interiors with it. I'll also introduce a few new features that I now added to this Blender add-on. So let's get back to business. Okay, as stated, so far we have explored the operation of the camera array tool using mainly object-centric methods. Now I will show you in more detail how we can prepare various interior 3D models in Blender and how we can utilize the so-called interior tower pre-made object in building a camera rig that will cover all the necessary angles of the room. For this project I have taken a basis of such a visualization of a living room that looks like a very comfortable and stylish place. I found this 3D model in the Blender Kit library, but like many models of this kind, they are designed to be viewed only from a couple of angles. Therefore, this model in question was completely missing object from one wall and was not designed as a complete room model at all. So I ended up inventing more furnitures and items that fit the style of the room. Since the room had large windows, I also decided to model a little view out to the yard, so that the view from the windows would be natural and would give more of sense of space than just a backdrop, which is often used in such visualizations. Since the Blender Kit library has a lot of different 3D objects and interior items, I got excited about decorating the space from over the tables and countertops a little so that they would not look so monotonous. I wanted to give the space a little bit of life and feeling that people have actually been in this room, so I thought these details would be important. When I got this virtual room to be as I wished, I started thinking about how it could be 3D scanned and built for photography using the camera array tool. And for this very purpose I have developed this pre-made object called interior tower, which can be activated from the add-ons drop-down menu here. This tower element is very simple object, consists of 3 boxes. When using this element, the cameras are supposed to be created pointing outwards. This way we get camera rig that shoots from 3 different heights in 4 different directions. But before we create these cameras, we need to modify this tower a bit. Of course, a single tower is not enough to shoot the entire room, so the idea is to duplicate this 3-box tower and take enough duplicates of it to cover the entire room from all sides. So we need to think about if we were actually in such a room, how we would scan it with a real camera, and how our roof bat would go around the room so that we don't hit or collide with the walls and furnitures. Okay, first I'll set the Blender so that I can see the room from directly above. This view is probably the easiest to view in wireframe mode, so I'll change the rendering of the view to that. Then I'll select the tower object and go to the edit mode. By pressing A, I'll select all the vertices of the tower boxes and move the entire object to this corner here. I'll take a moment to look at the tower from the side and make sure that the top box are at the right height near the ceiling. It is also a good idea to adjust the height of the middle box. You can also scale the boxes a little smaller. And now I'm ready to go back to the top view and press A again to select all the boxes. Then I'll press the Shift D to make a copy and then press X to move the copy in the X-axis direction. I place the copy at the suitable distance from the original and click it into place. After this, if I press the Shift-R shortcut, I can make a duplicate copy and it will be placed at the same distance from the previous one. I'll repeat pressing the Shift-R a few times so that I can copy these towers towards the next corner of the room. Then I will select the last tower piece by drawing a selection rectangle over it. And again, I'll make a duplicate copy of it by pressing Shift-D, and this time I'll move it on Y-axis direction. And again, by pressing the Shift-R shortcut key, I'll make more copies of these towers and move on upwards to the next corner of the room. By repeating this method in this way, I now copy these towers and go around the entire room. And I have to pay attention that the towers do not go inside the furnitures or go too near the objects, and that they will stay inside the room and is not placed outside the walls. I can also improve the position of these corner towers and rotate them about 45 degrees by pressing the R button. When I look at the statistics at the bottom of the Blender window, it shows how many faces are in these towers that I have copied. So in this way I can be aware how many cameras and images I am getting to render from this amount of these towers. The number is already quite high, so it is worth optimizing it a bit. And we can of course remove entire towers from those places that seems unnecessary, but mainly we should focus on these faces that will be too near of the walls or other objects in the room. If you create cameras on these face surfaces, they will have a problematic viewing angles and they will produce a useless pictures because they are too near of the surfaces of the room walls or other objects. So these type of faces should be removed from these towers. It can be done very easily from the top view by selecting the vertices with the rectangle selection tool. This way we will select the entire side of all these tower boxes and we can delete these faces by pressing the X or delete button. This optimizing step may be a bit tedious job, but it's worth doing it carefully because we don't want to end up rendering the unnecessary and useless images out of this room model. I myself managed to reduce the number of faces to 250 in the end, so I think that's a good enough number. Finally, when the tower setup is ready and well optimized, I can come out of the edit mode and create cameras for it with the Camera Array tool. And at this point, I want to introduce you to a new feature that allows us to create a new type of camera. It is an animated camera and it is an alternative way to produce images from array setup. After we have created cameras, we will have the option to use this new Create Cameras as an animation button. And this will generate each cameras created in the array collection on the timeline and create one new camera named Animated Camera. When we activate it, we notice that it has keyframe points on the timeline, and when we move the cue point there, we notice that the camera jumps to each array camera location. So this way we can now utilize Blender's own built-in rendering method and calculate all the camera angles out as an animation. And before rendering, we should also check the field of view values of the cameras. In situations like this, it is good to produce images with as much information as possible. So it is worth increasing the FOV values of the cameras to relatively wide angle so that each camera can see as much of the room as possible. I use a setting of 20 in this case. And now that everything seems to be in order, we can start the rendering process. If we want to use the new animated camera now, we can render the images out of it in normal way by using the Blender's own output directory and image settings. Just remember that if you later want to use the option of the camera array tool, such as COLMAP data, this output path should be set to the same folder as where the images of the animated camera will be rendered. Okay, but at this point I at least encountered the following problem. I was perhaps a little too eager at the beginning when I started to decorate this room. I didn't realize that all these numerous objects would of course require a huge amount of power and memory, and since I wanted to produce the best possible quality images, I of course used the Blender's own Cycles rendering engine. When I started the rendering process, I quickly came across the problem that my computer and especially my graphics card were running out of memory. So, what can be done in such situation? Luckily for me, I happened to be contacted by someone who offered me the opportunity to try out a rendering service in the cloud. A small Spanish team from Barcelona has launched a new service called Brender Cloud. It is a rendering service that is specifically focused on rendering Blender projects. Since Brender Cloud is still in the testing phase, they are looking for experimenters and volunteer testers for this service, and of course I was very excited about this. I have never tried rendering in such online services before, and especially now that I had a real need for one, it was interesting to try it out. Once I had my login credentials, the service itself was very intuitive to use. Brender Cloud can perform 3 types of rendering tasks. It can render animation frames, single large images, or if you know how, you can also implement custom rendering solutions via a Python script. My rendering task was simply to render all frames from a camera array setup through animation, so I uploaded my Blender file here to the cloud service. Before the actual rendering, the task will be analyzed, and Brender Cloud provides 3 preview images of the animation to be rendered. If everything looks good, the rendering job can be put into the production, and the Brender Cloud servers start producing the images. Depending on what level of service you are using, you have certain amount CPU processor at your disposal. I finally got the largest and the fastest option to test, where up to 8 servers took the images from my Blender file to calculate. So there was a lot of CPU power and VRAM memory available, so rendering 250 frames in total was an easy task for these servers. After some testing, I ended up rendering my project in 2 parts. Brender Cloud completed both of them in less than 2 hours. So more is more, and when you have enough power, anything can be produced really quickly. Now that I had all the images of this room rendered and had successfully downloaded them from the cloud, I was able to start training the Gaussian Splatting conversion in post-shot program. Because the rendered images are so clear, and there are reasonably many of them, it is not necessary to generate more data for Gaussian conversion, and the images can be fed into the post-shot as is. Post-shot can process all 250 source images relatively quickly, and ultimately it doesn't take that much time to produce the Gaussian splatting model. Camera tracking is able to produce a good solution and manage to solve the location of the cameras based on source images alone, and even the sparse point cloud becomes sufficiently accurate. So it is completely optional whether we want to generate COLMAP data separately from this model in Blender, as it is possible to train the Gaussian model from just the source images. Once the model is trained to the 30K iteration step, we can view it and move around inside the model in real time, and I think this is exactly the advantages of these synthetic model conversions. So once the pre-rendered images and the Gaussian training are done once, we can move around the model at this quality level in real time. The benefits are very noticeable, as we have seen how slow it can be to display a single image inside the Blender in this quality, and we cannot even think about moving inside this room in real time, even though we would have a very powerful graphics card installed on our computer. Only game engines have been able to do the same so far, and even in them this level of performance is achieved through a very special optimization and memory management methods. But now let's focus on examining this Gaussian model in more detail and check out how many images were ultimately used to train it. When we change the view in PostShot from this menu and select Image Set, we get to see what the source images turn out like. And now, if we move the cube pointer on the timeline, the images will flow through in the viewport. So the original number of the images was 250, and when we rewind this pointer near to the end, we notice that the images do not change after 237 images. So even though we gave PostShot the task of using all 250 images, it seems that some of these last ones are missing. In fact, a total of 13 images are missing. This means that the structure from motion process inside the PostShot did not manage to show all of these source images. 13 camera angles were ultimately left unresolved. It's not necessarily fatal, and it's very difficult to see which cameras are ultimately missing from the collection. But if we want to solve this issue and be perfect, we need to go back to the Blender and create official COLMAP data for all of these cameras. So this is going to be the last topic of this interior tutorial. Okay, so this first part of generating the COLMAP files is rather quick and easy. As I mentioned earlier, when we change this output path in Camera Array tool to point in the same folder where we stored those rendered images from those tower cameras, I have now added a small indicator here, which will tell us how many images it finds in that directory. So these images are now used in the COLMAP files when we press this Generate Cameras and Images TXT Files button. We can even check that out and make sure that the files are written in correct way by clicking this images.txt file open from the File Explorer. There we can see that in the end of these lines there are these image file names, which match to these original rendered images here in the folder. But now, the more challenging part is the point cloud data, which we still need to generate before we can get this thing to work correctly in the PostShot. Since this room is full of these small items and a lot of detailed objects, it's going to be very difficult to try to generate a point cloud from all of them. And that is not even the idea in here. We don't need the points from all of these furnitures and stuff which are inside this room. We are going to need only the so-called load-bearing structures from these premises. So if we take the top view again in Blender and zoom out enough so that we can see all the elements related to the room, we need to approach this thinking from outside in. What are the first objects that we encounter when we approach the center of the scene from far outside. So I can actually divide this whole thing in two parts. The walls of the room, the ceiling and the floor, which is one load-bearing structure, and then these outdoor spaces where the yard, fence and the backdrop elements are. I start carefully selecting these structures. I select the ceiling piece, floor, then these walls, and all these window frames, also separately, from both sides. And once they are all selected, I then go to the Advanced section in the Camera Array tool and open this Additional Tools menu. In here under I will find the Merge Object button. When I press it, the Blender thinks for a moment and produces a new object called Merged Points 3D Mesh. If I don't find it right away, I can search for it in the search field by typing the word merged in here. So this is a copy of the original objects that have all been merged into one object, and we can now do all kind of modifiers to this without messing the original parts. But first I want to move this merge objects to a new collection so I know what it is, and I will also give it a new name, room. Now, when I examine this room structure more closely, I see that it consists of only large boxes. It doesn't have many vertex points except for the edges. This is not really enough when we think about a point cloud. We would need more points on these wall surfaces, floor and ceiling, not only the edges. For this purpose, I have also added an Add Random Point Generator button to the Advanced Tools section. This is actually a geometry node modifier with which we can add points to the surface of the object randomly. When we look at the modifiers menu, we find a density control here, with which we can increase or decrease the number of the points. I want the room to have a relatively high number of points, so I set the value to 80. Now, next I will do the same procedure for the yard elements. I have merged the object together and then I add these random points to it. But I don't want these yard elements to be as dense as the previous one, so I only give it a density value of 5. Well, now we have 2 point clouds with different densities. Next we need to merge these into one object, so I'll use this merge function on them again. And this last created point cloud object is now the sparse point cloud, from which we will create the points3d txt file. This last part of the COLMAP data is saved in the same folder as the other txt files, and it is worth noting that it is written only with white dots. Since the process to creating it is so complicated, creating colored dots is very challenging, so we proceed with the white dots. Now the official COLMAP data for this interior is ready, so again we can drag all these files back to the post shot and start the Gaussian splatting training. Training with the white dots is a bit slower, but this is still a faster process than doing the camera tracking phase from the beginning with just images. Now the Gaussian process starts directly without the intermediate step. I think it is very interesting to watch how the dimension of the room, furniture and all the objects starts to appear in the places, even though the point cloud only contains the most necessary structural parts. However, it must be noted that not all the details may have time to be completed when we reach the 30K iteration steps. For example, this roof lamp in the middle of the living room is not ready, only this wire has had time to form from it. And also the landscape visible from the windows seems to have stuck in the surface of the window itself. So the training needs to continue. A model of this size should have time to develop into the complete model at about 80K iterations. So we have to be patient and let the training continue. Now when we check the image set again this time, we will notice that all the 250 images are now included. Since the COLMAP data contains labels for all cameras and reference to each images, we can be sure that nothing is left out of the final result. But eventually it remains to be assessed which implementation method is ultimately more sensible: to calculate the model with a few missing images directly in post-shot, or to take the trouble in Blender and generate the point clouds for the interior models in there. Either way, now I have shown you how this works and how interior models can be generated using the Camera Array tool. I would like to say a big thanks to the Brender Cloud team. Thanks for letting me to render these images for this project on your service. I am also very grateful to all of you who have already purchased my Camera Array tool from my Gumroad online store. This new version is now available there. And if you like the Blender Market online store more, I have now joined there as well, and this add-on is now also available in there. Let me know what you think of this tool in the comments. It would be interesting to know what kind of a project you have built with it. The Gaussian Splatting model built in this tutorial is now being added also to the Play Canvas new SuperSplat Gallery. You can visit in there and try out, for example, how it looks in VR mode. I'll leave the links in the description. I hope this video was useful to you, and as always, if you liked the video, hit the like button and don't forget to subscribe to my channel. Now I think that I will move from these interiors to the real-world exterior spaces next. Thanks for watching.